Good afternoon. So next we are going to see about fourth unit of object-oriented programming. The title of fourth unit is multi-threading and generic programming. The content of fourth unit is a difference between multi-threading and multitasking, thread life cycle, creating threads, synchronization of threads, and inter-thread communication, daemon threads, thread groups, generic programming, generic classes, generic methods, bounded types, and restriction and limitations. The first topic is multitasking. So when a single CPU performs several tasks at the same time, it's called as multitasking. It may be a task is a program, process, or threads. It's all called as tasks. In CPU, single CPU can perform a different operations is called as different operations at the same time is called as multitasking. To perform multitasking, the CPU switches among these tasks very frequently so that user can interact with each program simultaneously. So at each and every time, it will switch over its process between the tasks is called as multitasking. Next, multi-threading. Multiple threads are a single task to be processed by CPU at the same time. This is called multi-threading. Multiple threads are a single task to be processed by CPU at the same time. A thread is a basic execution unit which has its own program counter, set of the registers, and stack. Benefits of multi-threading: so increases responsiveness, resource sharing, memory allocation. So these three are the very important benefit of multi-threading. So next, comparison between the multitasking and multi-threading. So here we are having some parameters to make a comparison between multitasking and multi-threading. Basic has parameters basic, next switching, and then memory and resource. So in basic, multitasking makes a CPU to execute multiple tasks at the same time. In multi-threading lets execute multiple threads process simultaneously. In switching, in multitasking, CPU switches between programs frequently. In multi-threading, CPU switches between the threads frequently. Memory and resource, in which multitasking system has to allocate separate memory and resources to each program that CPU executes. In multi-threading, system has to allocate memory to a process. Multiple threads of that a process shares the same memory and resources allocated to the process. And next one is thread life cycle. So we are having several states in a thread life cycle. They are new, runnable, blocked, waiting, timed waiting, terminated. The thread life cycle. This is the diagram for thread life cycle. First, we have to start with the new state. It will go to the runnable. So from runnable, it may be go block or waiting or timed waiting or terminated. So based on the situation, it will go to the four states. Here, the first one is new. Its code is yet to be run and has not started its execution. Next state is runnable. A thread might actually be running or it might be ready run at any instant of time. The responsibility of the thread scheduler to give the thread time to run. Each and every thread runs for a short while and then pauses relinks the CPU to another thread. Next state is block. When the thread is waiting for IO to complete its life from blocked state, a thread in the state cannot continue its execution any further until it is moved to runnable state. A thread is in the waiting state when it waits for another thread on a condition. When this condition is fulfilled, the scheduler is notified and the waiting thread is moved to runnable state. Next step is timed waiting. The thread lies in this state until the timeout is completed or until a notification is received. The last state is terminated state because it exits normally. This happens when the code of thread has entirely executed by the program because there occurred some unusual erroneous event like a segmentation fault or an unhandled exception. Next, how we are going to create a thread. We are going to see here. Threading is a facility to allow multiple tasks to run concurrently within a single process. Threads are independent, concurrent execution on a program, and each thread has its own stack. Ways to create a thread by extending thread class by implementing runnable interfaces. Java thread benefits. Java threads are lightweight compared to process as they take less time and resources to create a thread. Threads share their parent process data and code. Context switching between thread is usually less expensive than a process than between processes. Thread intercommunication is relatively easy than process communication. Thread class. Thread class provides constructors and records to create and perform operations on the thread. Thread class extend object class and implement runnable interface. Constructors of thread class. Thread, thread string name, thread runnable or comma string name. So we are having some methods of thread class. Public void run, public void start, public void split, public void join, public int get priority, public set priority, public string get name, public void set name, public boolean is aligned. So naming thread. The next one is naming thread. Each thread has a name that is thread 0, thread 1, and so on. The syntax of set name and get name method are given below. Public string get name is used to return the name of thread. Public void set name string name is used to change the name of the thread. The next step, extending a thread. The way to create a thread is to create a new class that executes thread, and then to create an instance of that class. The extending class must override the run method, which is the entry point for the new thread. It must also call start to be execute of the new thread. So this is the example for the thread program. So we will see these programs in laboratory session. So in creating thread, next we are going to see implementing thread. To create a thread is to create a class that implements a runnable interface. Runnable abstracts a unit of executable code. To implement runnable, the class need only implement a single method called run, which is declared as public void. After the new thread is created, it will not start running until we call its start method, which is declared within thread. So that is void start. So next, so regarding this, the implementing thread program, we will see in a laboratory session as usual. Next, creating multiple threads. We are using some methods like isalive, join, isalive, and use join to wait for a thread to finish. So the final keyword is used with the void join, those interrupted exception. So regarding this, the programs are we will see in the laboratory session. So we will see in the next class. Thank you.